Mercury. Mercury sits closer to the Sun than any other planet, and most people assume that means it is the hottest. It is not, but that does not make it safe. During the day, surface temperatures reach 430 degrees Celsius, hot enough to melt lead. But because Mercury has no real atmosphere to retain heat, the moment the Sun drops below the horizon, the temperature collapses to minus 180 degrees Celsius. That is a swing of more than 600 degrees between day and night on the same planet. Solar irradiance on Mercury is between 4.6 and 10.6 times stronger than on Earth, depending on its position in its elliptical orbit. A single Mercury day, measured from one sunrise to the next, lasts 176 Earth days. So landing in daylight means baking for months. Landing at night means freezing for months. Your only option is a narrow region called the terminator zone, the moving boundary between day and night, where temperatures fall within a more moderate range. Current NASA spacesuits are rated to operate between minus 157 and plus 121 degrees Celsius. In the terminator zone, where temperatures stay within that range, a suit could theoretically function. But Mercury has no atmosphere whatsoever. A complete vacuum, which means the suit's insulation would be working at its absolute limit with zero margin for error. One failure, one crack, one seal that gives way, and it is over instantly. This is not a place where equipment is allowed to have bad days. Venus. Venus is the second planet from the Sun, but it holds a title that surprises most people. It is the hottest planet in the solar system, not Mercury. The journey from Earth takes approximately 4 months. As you approach, you would see thick yellow clouds. They are beautiful. They are also made entirely of sulfuric acid. Below those clouds, the atmosphere is 96.5% carbon dioxide and 3.5% nitrogen. As you descend, invisibility drops to almost nothing as the air becomes almost liquid in density. The average surface temperature is 464 degrees Celsius. The pressure at the surface is 92 times greater than Earth's sea level pressure, equivalent to being nearly 1 kilometer underwater in Earth's ocean. This is where Venus is fundamentally different from Mercury. On Mercury, the danger is temperature and vacuum. A suit could theoretically survive in the right zone. On Venus, the pressure alone would structurally destroy any suit ever built, regardless of temperature protection. The suit does not overheat first. It does not dissolve first. It is physically crushed first. The most durable lander humanity has ever sent to Venus, the Soviet Venera 13, survived 127 minutes before being destroyed. You would not last 2 minutes. Mars. Mars is the most habitable planet in the solar system outside of Earth. That is not a compliment. It simply means it is the least immediately lethal. Daytime temperatures near the equator can reach 20 degrees Celsius. That sounds almost manageable, but Mars nights are a different matter entirely. Temperatures plunge to as low as minus 153 degrees Celsius. The average surface temperature across the entire planet is minus 62 degrees Celsius. The atmosphere is less than 1% the pressure of Earth's, composed of 95% carbon dioxide with trace amounts of nitrogen and argon. That thin atmosphere provides almost no protection from cosmic radiation or solar particles. NASA's Curiosity rover recorded approximately 300 millisieverts of radiation per year on the Martian surface, roughly 40 to 50 times the average annual radiation exposure on Earth. Long-term exposure at that level would significantly increase cancer risk for any human crew. Then there are the dust storms. Mars experiences global storms that can last for months, covering the entire planet, with wind speeds reaching 100 kilometers per hour. While the thin air means those winds carry far less physical force than equivalent speeds on Earth, they coat every surface in fine dust and cut off solar power entirely. That is exactly what ended NASA's Opportunity rover mission in 2018. Any human presence on Mars would require a fully pressurized, radiation-shielded, airtight habitat. The planet will not kill you in seconds. It will just make survival extraordinarily difficult and expensive at every moment. Jupiter. Jupiter is where planetary survival stops being difficult and becomes physically impossible. Even before you arrive, Jupiter's radiation belts would begin penetrating your spacecraft hundreds of thousands of kilometers from the planet. No current technology can shield a human from Jupiter's radiation environment for any meaningful length of time. Assume for a moment you could survive the radiation. So as you enter the upper atmosphere, you encounter clouds of frozen ammonia crystals at around minus 150 degrees Celsius. Wind speeds in the deeper atmosphere, measured by NASA's Galileo probe, reached 610 kilometers per hour, faster than any wind ever recorded on Earth. The Galileo probe, the only object humanity has ever sent into Jupiter's atmosphere, survived a descent of 165 kilometers before it was destroyed by pressure and heat in 1995. Below that point, a pressure and temperature rise continuously. Eventually, you reach a layer of supercritical hydrogen, a state of matter that behaves neither as a gas nor a liquid. Deeper still, hydrogen transitions into metallic hydrogen under immense pressure. At the theoretical core, temperatures reach an estimated 20,000 degrees Celsius. roughly 3.6 times hotter than the surface of the sun. There is no ground to land on. There is no surface to stand on. There is only increasing pressure, increasing heat, and increasing density until there is nothing left of you at all. Saturn. Saturn is Jupiter's quieter sibling in appearance, and its more violent twin in behavior. Approaching Saturn, you would need to navigate 146 confirmed moons, the result of ongoing discoveries, with the latest confirmed count reaching 146 as of 2023 and 2024 surveys. You would then pass through the ring system, billions of chunks of ice and rock ranging from grains of sand to objects the size of houses, all moving at high orbital velocities. Saturn's atmosphere is 96% hydrogen and 4% helium. If you reach the upper atmosphere, you would encounter winds of up to 1,755 kilometers per hour, the second fastest sustained winds in the solar system. The mean atmospheric temperature is minus 140 degrees Celsius. Saturn's North Pole hosts a permanent hexagonal storm system large enough to contain multiple Earths simultaneously. As you descend, the gas gradually transitions into liquid. At Saturn's core, roughly 10 times the mass of Earth, temperatures reach approximately 11,700 degrees Celsius, more than twice the temperature of the sun's surface. You would never come close to it. The pressure would have destroyed you long before. Uranus. Uranus holds a specific record worth understanding precisely. It has the lowest single temperature ever recorded on any planet in the solar system, minus 224.2 degrees Celsius. But this requires an important clarification. That figure is a minimum recorded dip, not Uranus's average. Neptune, being farther from the sun, actually maintains a colder average temperature day to day. The reason Uranus hits these extreme lows is that it generates almost no internal heat whatsoever. So when its poles point away from the sun during its unusual orbit, there is nothing to compensate, and temperatures collapse to record levels. Neptune stays consistently cold. Uranus occasionally becomes catastrophically cold. Uranus is also the only planet that rotates on its side. Its axis is tilted at 97.77 degrees, meaning it essentially rolls around the sun like a barrel. One day on Uranus lasts 17.2 Earth hours. Entering Uranus would mean descending through poisonous freezing gas before being struck by ice particles. Then comes one of the most extraordinary phenomena in the solar system, diamond rain. At sufficient depth, extreme pressure breaks down methane molecules, freeing carbon atoms that compress into diamond crystals and fall through the mantle like hailstones. The pressure at that layer is approximately 100 times Earth's atmospheric pressure. The diamonds cannot save you. They are falling alongside whatever remains of you by the time you reach that depth. Neptune. Neptune is 30.1 astronomical units from the sun, 30 times farther than Earth. Light from the sun takes over 4 hours to reach it. Getting there from Earth would take approximately 12 years at current spacecraft speeds. When you arrived, you would find the most violent sustained winds of any planet in the solar system. Neptune's wind speeds have been measured at up to 2,100 kilometers per hour, nearly twice the speed of sound in Earth's atmosphere. The outer atmosphere sits at around minus 200 degrees Celsius, and unlike Uranus, this cold is consistent, not episodic, because Neptune is simply that far from any source of warmth. Sunlight on Neptune is around 900 times weaker than on Earth, producing not true darkness but a state of perpetual twilight, the kind of dim, gray half-light you might see on Earth just after the sun has set. Faint, cold, and entirely without warmth. Neptune does have a powerful internal heat source. Its core radiates significantly more energy than it receives from the sun. That core reaches an estimated 5,100 degrees Celsius, just slightly below the temperature of the sun's surface. Neptune also experiences diamond rain at a depth of approximately 7,000 kilometers, where extreme pressure decomposes methane into solid diamond crystals. It is more massive, more active, and in most meaningful ways more extreme than Uranus. The two planets are similar in composition but not in behavior. Outro: 8 planets. 8 different ways the solar system ends a human life. Mercury burns you, or freezes you, on it with a vacuum that gives your suit no room for error. Venus crushes and dissolves you before you reach the ground. Mars irradiates you slowly while dust storms cut your power. Jupiter erases you under pressure before you ever find a surface. Saturn tears you apart in winds faster than a bullet. Surrounded by 146 moons and billions of pieces of orbiting debris, Uranus freezes you in the coldest temperature ever recorded on any planet. And Neptune carries you through supersonic storms in a world of perpetual twilight, 4.5 billion kilometers from home. The universe is not hostile. It is simply indifferent, and the margin within which life is possible is far thinner than any of these planets will ever let you forget.